This conference will now be recorded.
Hello, friends. A very warm welcome. I hope all of you are doing good. So, this is Ishant on behalf of Auribises, and I hope everyone is coding up to the levels. So, I have Arshdeep, Divya, Jasnoor, Karthik, Navjot, Pradeep, Rhythm, Roop Kaval, Sahib, Sahil, Saloni, Sarthak, Shashi, Shipali, Shimpa, Shivani, and Somya with me as of now. So, guys, in our last discussions, we have seen what is meant by a CNN. So, having a convolutional neural network will allow you to train the models and you do image classifications. Now, to solve day-to-day problems, now for an example, if you would like to recognize a face, so you need not to create the CNN model from the scratch, okay? So we do have libraries and the built-in models. So nowadays we have so many models which are already trained with the various data sets. So you need not to kind of, create the model from the scratch, train it with the data sets. So rather you use those models and further create apps based on them. So today I'm going to introduce you guys with a library called face recognition. So this is the library with the help of which you can create a model, right, and train the model with the face, and it's gonna come up with an accuracy of 99.38% because it's gonna use a deep learning library called DLib. Okay, so guys, what exactly we have to do today is we'll be understanding what is this face recognition library. So this face recognition library is supposed to be installed, but before we install the face recognition library, we need to install this dlib. So dlib is a C++ library, okay? And to install the dlib, so there is a CMake which has to be installed, but you can just go through the Google, right? This is a very basic way how you can come up with the installations. So let me come up here. So the whole discussion today is to understand about the library called face recognition, right? So this is the library which we are going to install. So prerequisite is installation of dlib, and if the dlib is not installed on your system, you cannot use the face recognition module. Okay, so you just need to just explore on the installation of dlib. So it's not that complicated, and there are so many blogs out there that how you can install dlib in your system. So you just need to come up and say pip install dlib, and you need to say pip install face recognition. All right, so these are the two libraries which you need to install. So please make sure that they are installed, and then you do use this library. So pip install face recognition. So coming here, this library is going to feature us various works, right? Various small examples on how you can actually work, right? Now you import face recognition module. So there will be an image. So you load the image file, you put any JPEG image, right? So thereafter you can come to know the locations of the face very easily. So for example, this is one image as input, and the output is you are able to extract two faces from the image, right? Even the blur of the image can be extracted very well. So this entire library, face recognition library, is based on this deep learning library, dlib. It's a C++ library, right? If you want to explore this, you can even do. So there is this deep learning algorithm, right? This is like 99% accurate algorithm. So that's the reason I'm not saying you guys that you should be directly writing a CNN or doing some image face recognition concept here and there. So directly use this library and implement in your project work. So guys, what we have to do is, so this is one of the examples here, okay? So there has to be there has to be a video stream which will help us to tell who is who, okay? So if you see, even from the phone, right, if the user is trying to put up and the face is recognized. So this is the example program which we are going to explore today. Okay, so let us see how. So here we have the link to the example code. So this library is already there on the official link pypy.org. So I'll just say see this example code. So guys, this is the example code if you can see now. So what we see is that there is this module called face underscore recognition, then the CV2 and the NumPy. So three libraries are being used, right? So face recognition will internally use dlib so that we can somehow, kind of do the deep learning for the face recognition. So what I'll do is I'll just take up this program and put it in a Python file. So we're gonna use this. So this is one of the example snippets from the library tutorials, right? So let us try to see what is what, okay? So this is very much self-explanatory program. So we have already seen this cv2.video capture. So it's gonna capture the video. Now we need to have a few images for which we would like to make the model learn and recognize the same, okay? So guys, I just copied these two of the images. Just give me a moment. So one is with the actor Ritik, if you can see here. Then the other one is with the another actor called Amir Khan, right? So we got these two images here, right? We're gonna train the model on these two images. So the first image belongs to, let's say, Hrithik Roshan, and the second images belong to the second person. So I'm just gonna have these images. So let me tell you what exactly the code is and how it's gonna work as well, okay? So the first part here is face recognition dot load the image file. So you are going to read the image file. So you got this image file, and now we are trying to do the face encodings over here. So face encodings is like you got the image, and from the image you got the encoded face. Okay, so we got the face encoding coming here, which is basically the zeroth index of your HR image, the image which you read. So your face encodings will give you some processing result, right? And it's gonna be the zeroth index. Same way, I'm gonna load the other image for the other actor. So this is going to be the another image for us. So we are training two faces here, right? One for the Ritik and one for the Amir. So coming here, this is your array of known faces, right? So one is your HR face encoding, another one is AK face encoding. So we are going to have these two names here, right? So the known face names is a list and the known face encodings is a list. So what we can do is we can read as many as images we want, and we just need to somehow create the encodings for those images, which is going to give us the encoding for the face, and all those known encodings are supposed to be created in a list with their names, right? So this is the data set creation. It's a very easy structure. So first of all, this video capture is to start the webcam, right? It's gonna start the cam of your system. Now this is like you have the data and you are preparing the data set, right? This is the preparation of the data set. Guys, can I get a smiley from all of you here? Are we good to go? Anyone having any query can please post on the chat box. If you are good to go, please acknowledge with a smiley. So not that difficult and not that challenging at the same time, right? This code is not written by me. So it's one of the libraries called face recognition. From the face recognition library, we are taking down their example, right? How to recognize faces. Now, the next is, so they got these three lists: the face locations, the face encodings, and the face names. And there is a variable called process this frame as true. Okay, so these are the some of the variables, right, which are required to process the algorithmic part of the program. So while true, so we are going to run an infinite loop. For running this infinite loop, every time we are reading a frame from the video, right? So if you can recall, so video capture is cv2.video capture of 0, right? So we are going to read the image. We are going to read the frame from the video from the webcam. Now you resize the frame. So basically what is done here, so resizing the image frame in 1/4, right? So you are just doing 1/4 of your image, which is read as a frame from the webcam. So we say f of x as 0.25 and fy as 0.25, right? Thereafter, we are going to convert the image to the RGB mode. So that's like we got a small frame, that's like resizing the frame, and the frame is now converted to the RGB mode. Okay, so red, green, blue. Now, in case the value of process this frame is true, so that is true, right? So the process this frame variable is true. So what we are going to do is we're going to process the frame. Now, uh, for this small RGB frame, we are going to find the face locations, and then we are going to get the face encodings. And now, if the face encoding of the current frame is available in these unknown face encodings, right? If it is going to be there in the known face encodings, if it's going to match there, so it's going to work for us, right? So what we do is we match, we compare the faces in the known face encodings, right? By default, the value of the name is unknown, so we have taken up a variable as unknown. Now, in case we have a match, in case you have a match, right? So for that, we need an index. So guys, the face distances is basically a distance of the face, right? And the numpy dot minimum mark is going to give me the index of this known face name list from where I can extract the name, right? So in case we get that, so we'll append the name in the face names, and process this frame becomes not of process this frame. So it means that we need not to further process the frame, right? Because we found a known face. So once again, let us try to see this algorithm. So what we did, we are trying to find all the faces available in the video, right? So if in the video we have three faces, we will be capturing those three faces, right? So face location is going to give me all the faces, and of all faces you are going to have these face encodings. Now the next is you iterate in these face encodings, and for every face encoding available in the video frame. So let me show you here. Now in this video stream, we got two faces and now three faces, right? So one frame may have multiple faces. That is what you need to understand. So what we are doing here is we are trying to first of all extract all the faces from the frame. Let me write this here. So what we are doing is extracting faces, and once you extracted the faces, so the next part for us is basically get the face encoding. So you did the face encoding for the faces which you know, right? So they are the known face encodings and the known face names. These are supposed to be in the video, that you got some faces in the video, right? And you are trying to work on that. Okay. Now the next is what? We iterate in all those faces which we found in the frame. So we are comparing the faces and you get the matches. So there is a variable called name which is unknown, right? So for something which is unknown, the name shall remain unknown. Just give me a moment here. Now face recognition dot face distance is going to calculate the distance to the new face, the smallest distance to the new face, and you find the minimum value towards the best match. That becomes the index, right? And in case in the matches you have that best match index, so you are going to extract the name from the known faces. So otherwise the value of name is going to be unknown for you. And once you are done with this, you just say not process the frame further. Guys, can I get a smiley here? Are we good to go? I think this is not that complicated one, right? If you want, you can just try to. Shimpa, let's say there is this face A and a face B and another face C. So for example, there are three faces here in this video, right? So let me try to put this across in this manner. So assuming that you have these three faces, these are three known faces to us, okay? All the faces are known to us. So in one video stream, in one frame, you have some faces. Let's say three faces. So what we are doing is, the very first part, we are getting all the faces, then we are getting the face encodings. Now we need to know, so whatever the face we have is closest to which of the known faces. So that is going to be the distance here, right? So the face distance is basically the distance of the unknown face which is closest to these faces. So if we sort of achieve this, right? If we sort of achieve this, we get to know the minimum distance. So that's gonna be the index which we have found, and thereafter we're gonna append the face names, and we're gonna stop the processing. So guys, next is displaying the results. So you got this top right, bottom left, and name in the face location and the face names, right? So there is something where we are trying to come up and create one small rectangle. Okay. So the top is multiplied by 4, right is multiplied by 4, bottom is multiplied by 4, and left is multiplied by 4, right? So basically this is scaling the images back to the original size, because we kind of did it 1 by 4 here, right? So you made the frame to go small to process. So on the CV2, we will draw a rectangle on the frame with the left top, right bottom. It's gonna be 00255. So red, green, blue values, right? Same way, we are going to draw another label. So another label is like where you're gonna put up the text. So you got a rectangle and you're gonna put up a text, right? So there is some font for the text which is like some Hershey duplex, and lastly you will say cv2.image show the video and the frame. This is going to show you the resulting image on top of it, and at the same time if you hit Q, so you will be exiting your video. So let me try to show you guys how it's gonna work for us now. So before that, anyone having any query? So are we all good to go before we execute the program? So guys, this is like displaying of these rectangles, right? So you have this one rectangle, another rectangle with this filled red color, and then the text written in it. So drawing of the rectangle on the CV2. So let's try to run this program and see how it's gonna work for us. All right, so here I am, right? If you can see. So just give me a moment here. So here I am, right? So it says either unknown or Amir, right? Unknown itself. So I'll just bring down this another face. It says this guy is unknown. Let me bring one more face here. So it says it's Amir. I hope this makes a sense to everyone how this program is working for all of us. Can I get a smiley from all of you? Are we good to go, guys? Now, what we can do with program can be done with this sort create one app. You can take the dates even so. This we do is you can create which detects eyes. You can detect the blinking of eyes. Okay, so there may be the person who will blink the eyes, and when the person blinking the eye who we have already recognized, you mark the guy's attendance. You can have a very basic project, right, on the attendance management system, and thereafter you can even do an analysis on the attendance. Then you can use the same program to use it as an admit card for your exams. Okay, so of course there may be more refinements available, right? This is not the perfect use case. So create a program which detects the blinking of eyes for real time analysis, for real time detection, for live detection, right? So you can actually get so many Python programs available with this face recognition and delete module, how you can get the blinking of eyes, and how you can detect the frame in a live way. So guys, are we all good to go till here? Smiley awaited from all of you. Is this program clear? So let me share these links with all of you. So this is an example link which we follow. Now there are more examples with the face recognition library. Okay, so this is not just one example. There are so many other examples which are underlying and explained here. So if you can see here, right, so recognizes faces in live video, right? Slower version, faster version. Then recognize faces with a K nearest neighbor classifier. So many of you can just kind of write the projects and you can finish off. So face delay, right? So please see, install delay before you install face recognition, and delay installing delay needs CMake tool to be installed. So you will get it over the Google, right? You can just browse it over the Google, and it's not that challenging thing where it will be any problem to anyone. Okay. Now, how we can kind of integrate this project with the Flask? that may be a more relevant part for us, right? So how we are going to come up and integrate the same project with the Flask. So a small break of 5, and thereafter we are going to see how. So guys, welcome back. So now what we're gonna see is we're gonna see that how we can create web streaming in the Flask, right? And thereafter I'll give you one small exercise that how you can integrate this program with that program. Okay. So the first thing first is let's come here in the templates directory. So we have already sort of explored what is Flask, right? So I'll create a new file. This may be video stream.html. So very quickly, I'll take few snippets here and there. So this is going to be your, let's say, face recognition. This is web streaming for face recognition. I'm going to do a partial program here, guys, not the entire part here. So let's have a couple of breaks here. So I'll remove this frame. So instead of the frame, I'm going to have this tag called image. So guys, for the image, what is going to be the source, right? So typically we put a JPG image in this tag so that you can get to see an image. But what I'll do is I'll use this dependency injection here, and we'll use this URL underscore for. So here I'm going to put one URL pattern. This is like video, right? So what we are trying to do here is we're trying to get images from some Flask app function with the URL pattern as video, right? We'll see it. It's gonna make more sense when we are going to write our Python Flask app. So let's see how we can do that. So let me write this new Python file. This goes like your session number 67A. So here I am going to import, let's say from Flask, you import the Flask. Then similarly, I have few more APIs to be imported from the Flask. One is going to be the render template. Another one is going to be the response, right? These are the three APIs which I would like to get from your Flask. And of course, we'll import this CV2. I would like to do something with respect to video streaming. So for video streaming, we have one more library called imutils. So you can go ahead and you can even install this library called imutils, image utils, pip install imutils. Okay. So this I already have it in my system. So we need not to have it again. So this pip install imutils is the image utils. So rather than with the CV2, we have the other library with the help of which you can do a video streaming. A bit lighter one, right, as compared to OpenCV. So from imutils.video, I'm going to import something known as video stream. So for this, guys, pip install imutils, right, in case the library is not there. So you should be having it in this way. I'll also import time, right? So let's see why. I'll tell why we'll be doing this. And I'm just going to import the imutils in itself as well. Now let us create an app which is by default the Flask with the name, right? So we got this app. Then I'll say video stream is going to be your video stream. Guys, this is the object of this class video stream which I'm going to create. And here to begin with, the source is going to be 0. We're gonna begin from the scratch, and then you say start. So this is a stream of video that's like a lot of frames you are going to get. But what we want is we want to start everything after some time interval. So I'm just going to make a sleep of 2 seconds. So let the main thread sleep for 2 seconds, and then we will start video streaming. So typically for the first 2 seconds, right, sometimes the program may take time for video stream to initialize. So we are just going to come up and do a small delay here. So it's a small delay. So let us define the home page, or let us define the index for our app. And for the index of this app, right, I'll say @app.route. So this is going to be the index page. So we'll say return us the render template, which is your video stream.html. So let us see what we did, guys. In case, so let me just finish off this part of very basic structure of Flask. Right. So here we go. Now the name is main. So we say app.run. So the moment your app will execute, so the index page is going to be this video stream.html. And What is the video stream.html? It's just one basic page where you have this heading and an image source coming up, right? And this guy is looking forward to fetch the data from this URL pattern video. Okay, so in my 67a, I'm going to say define, let's say a function called video, right? And this guy is app.route video. So this is what we have here. So my video stream.html will populate the image from this URL pattern video, right? It's gonna execute this function video for us. So can I get an acknowledgement? So as I'm just going to write the path here. So till here we are good to go, guys. You got this video stream. So it's a stream of frames. We got a Flask app. It's gonna start after 2 seconds, right? We're gonna start everything after 2 seconds. There is a halt of 2 seconds. Now this is optional, okay? If you want to skip, you can skip that. I'm just going to skip it. That's perfectly fine, right? So you can skip that. So now how are we going to populate the stream of frames on the web page? For that, I'm going to write one more function. Okay, let's see how. So you say define generate frames, and this function is going to have a loop. While true, it means you're gonna run infinitely. So from this video stream, we're gonna capture the frames. So I'll say frame is your video stream dot read. So you read the frame from the video stream, and what I can do next is I can resize. So I can create another frame which is going to be your imutils dot resize the frame, where we are going to take the value of width to be let's say 600, right? So we got another frame, we got a resized frame here. Now with the OpenCV, so with the OpenCV, I'm going to do an image encoding. Let us see how. So I'll say cv2 dot, so this goes like im encode function. So in the im encode function, you are going to make sure that your frame is encoded as a JPG image, and what you will get is a tuple as a result. All right, so in the tuple we got flags and the encoded image. So guys, this encoded image is your frame which we converted it to as a JPG image. So size src is the source, right? You're gonna begin from the video stream. So the default value is supposed to be 0. Now in this function, right, in the generate frames, I'm going to now say yield. Guys, can you remember what is yield? So yield is going to convert your function into a generator. So this loop will run infinitely, and every time when we execute this function called yield, it's gonna return a new frame, and this is going to be something like this. So just give me a moment. So it's gonna be a binary. So I'm just gonna mention a command here, so just give me a moment. So guys, this is where we are trying to certainly do some headers. So you're doing some more encoding. So plus the byte array from the encoded image, and we are just going to further say a plus of -r and -n. Okay, so this is something which you are trying to, so you just need to understand one very basic type. So we are going to return this image type. The MIME type is image, a JPEG image. So this encoded image you are going to return back. Okay, so this is one of the encoding structures. Now in this video function, I am just going to write a return of what, right? I'm going to return a response. I'm going to create a response. So this response is imported from the Flask. You're going to create a response object, and response object is going to execute the generate frames. So your generate frames function is going to give you one encoded image in return, and along with this we are going to say a MIME type, which is going to be your multi-part, then x mixed replace. So this is the MIME type, right, for the image, and there is supposed to be a boundary which is going to be the frame. Now the two different things which you would have never heard of the part before is this encoding of the image, right? So this is how is the industrial standard, that you are just going to encode the images over the web. Okay, so we are not going to talk much of the web part here. That is the reason you are unable to deal with this part. So next is what now? So the next part is that we should run this program, and the moment you run this program, so the index image, the index part over here is this video stream.html, and you get to see some frames on your web application. So your web application started here. Let me open this 5000. So here you are, guys, once again web streaming for the face recognition. So you got this face recognition tutorial, and you got this web streaming tutorial. So now here you need to come up and somehow tell that this face belongs to whom. All right, so this is web streaming when it comes to your face recognition tutorial. Now you need to mix session 67 67A, right? So that's the assignment for the day, and of course you can now proceed towards your basic project ideas. So integrate session 67 in session 67A. So start working on face recognition projects, right? And the basic goes like, for example, attendance management, very basic project to begin with, right? So thereafter in attendance management you can even save the data in the database. We have already seen that how you can store the data in the database. Every student will have an ID, and to precise, the ID is gonna be a face ID. And when I say face ID, the ID can be this face encoding. You can just print this face encoding and you can see what is the data, how the data is represented, how the things are working here. So this is a quick introduction on what we can do with respect to the face recognition. You need not to code the CNNs from the scratch. And tomorrow I'm going to introduce you guys what are the various pre-trained models available in the industry and how you can use one of them in your Python programs. So guys, anyone with any query can please raise the same. In the meanwhile, I'll just push the code over the GitHub. So you just need to work on your images. So I'm not pushing these images. So images you guys can work yourself, guys. Okay. So I'm not pushing the Amir and the Ritik images. That's the only thing. So face recognition and web streaming in Flask. So two things which we have explored here. So please go through them, code them, and start working on the projects in case you are planning with some face recognition structures. All right, guys. Anyone with any query here? So Ashdeep, Divya, Gagan, Hitali, Jasnood, Kamal, Maninder, Navjot, Neha, Palvi, Pradeep, Ridham, Roop Kaval, Sahib, Sahil, Saloni, Sarthak, Shashi, Shipali, Shimpa, Shivani, and Somya, guys. Can I get an acknowledgement of the smiley so that we can proceed towards closing the session? Other way around, please, you can raise your queries. So guys, these are all built-in structures which we are now kind of using. So you do have a knowledge on Python, you do have a knowledge on ML, you do have a knowledge on how you can write an artificial neural network from the scratch, including the CNN parts. So now we are going to further use the APIs and work on our application ideas. Okay, so this session is not that complicated, so please definitely try to attempt your face recognition ideas here now. Thank you. Have a wonderful time ahead, guys. See you tomorrow. Thank you. Bye bye.